Hey, good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. My name is Jeff Fritz, and this is C# with CSharpFritz. We're going to be talking about getting started with C#, the programming language, getting you some of that information, answering your questions about how to get started and get involved and become a .NET developer. We're going to be doing that with live examples right here in the browser that you can follow along with as I'm writing code here. Everything's running using Jupyter Notebooks and .NET Interactive, and you're going to be able to use a link from Binder. And if you're watching the YouTube video, it's just below here. I'm going to post that link into chat in just a minute. And today's actually kind of a special episode. Today we're going to do something a little bit different. We're going to get in, and this is going to be the Errata review. We're 6 episodes into the series now. We've gone through and covered a bunch of different topics, but we could have gone a little bit deeper. We could have gone into a little bit more details, a little bit more features that we skipped through. Either we ran out of time or we had questions that came up that distracted us from some of those deeper topics, or we got questions that asked, hey, you know what? I want to know a little bit more about a certain feature and I haven't been able to address it yet. That's the agenda today. Is we're going to go through and we're going to talk about the errata of the last 6 episodes that we've had together, kind of summarize and go across the gamut and get you those updates, show you some tools, some features that will make your development experience a little bit better. Let me say hello to the folks that are here in the chat room. Oh my goodness, I see a bunch of friends already. Look at that. Boop5 is here. Kiter1, hello, hello. Saduki, good morning to you. That's our friend Sarah Dukevich. She's a Microsoft MVP. Welcome in. KW Mannion, good afternoon to you. Shy Sharp is here. The original CMJ, Chris Jones. Hello, hello. Frank Boucher is here. Hello, hello. And we got Raiders coming in from Uillas. Oh my gosh. Welcome in. Hello, hello. Thank you, Raiders. Appreciate you sending folks over here to join us. Tail Learn Code is here. Good morning to you and the C# community. Yes, indeed. Grumpf. And Paul Oliard from Brazil. Hello, hello. Good to see you. So Frank's another Microsoft employee. Welcome in. Garcia, how's it going there? And I want to make sure that you know where you can, as folks are filing in here, Viral Flows. Hello. Thank you so much for the raid, Uillis. Let us know what you were doing over there on your channel. And we'll make sure we get a... Well, I don't have a shout-out feature here on the Visual Studio channel. Make sure you check out Uillas. Thank you so much for that raid. Vicente Jr. Hello, hello. Where's everybody dialed in from this morning? It's been a week since I've been here with you. 2 weeks, actually, since I've been here with you. Let us know. Drop a line in chat there so we can see some of the locations that folks are connecting in from. Brazil and Rio de Janeiro. Oh, my goodness. Is where Dev Nelson is. Give it a second there there's a delay coming in here. Western Canada, sunny Scotland. Now, sunny in Scotland. I didn't know that actually went together too well. That's like sunny Seattle, right? We know it's always sunny in Philadelphia, but Seattle? Oh my goodness. All right. Chester Springs, Pennsylvania is where Yash, is that Yash Shabria? Welcome in. Hello, hello. Rainy Germany. Okay, there you go. Oh, it's so good to see everybody. It's great to be back after I took a little bit of time off. And let's take a look at our GitHub repository. I'll share the link into chat over there so folks can go through and click in and see a little bit of the status, where we are with the show, some of the other notebooks that we've worked on here, some of the lessons that we've gone through, and click through to that important link that'll get you started, that'll get you kicked off with running the samples live in your browser. Like I said, if you're watching the YouTube video, check the description just below. You can click a link there that'll jump you right into the GitHub repository I just shared over there with the chat room. Let me head over to the code here and we'll take a look at that GitHub repository. And shuffling it around, shuffling. Let me put on my gunner glasses here. We can get started. I've got my Visual Studio Live Share hat on. Big fans of Visual Studio Live Share, and actually I believe starting next week, we're going to move and start using Visual Studio Code for our samples, because we're going to get a little bit further outside of just basic C# here. We're going to start to get into class hierarchies. We're going to start to get into a little bit of interacting with various levels of integrating with data, integrating with web servers, integrating with different services, and it's going to be much more beneficial to show you that with Visual Studio Code. Woadcraft from windy Denmark. Oh my gosh, welcome in, so good to see you. I'm going to get some music playing here in the background. Here's our GitHub repository that you can take a look at. This is Streambeats synthwave playlist from our friend Harris Heller. Let me get that dialed in here. This is a collection of groovy music that you can listen to that's copyright free, and it's licensed for you to be able to use with your YouTube channel, with your Twitch streams, anywhere that you might find it appropriate to have a little bit of background music. And this playlist in particular is set up to be a little tech, a little pop, that's kind of groovy to have in the background while we're talking about code and technology together. Thank you so much, Harris. We appreciate you sharing your music for us to listen to here on the stream. So this is the GitHub repository. There's a series of issues here. There's a couple of projects. And if you have questions as we're going along, if you're particularly catching the YouTube channel, you can, of course, put questions just below. But if you're watching a recording, if you're watching a repeat, you can come in here to the Issues tab, and you can log an issue with a question, a feature that you might want us to cover in a future episode. Do I have a link to the Streambeats playlist? If you go to YouTube and you search for Streambeats, or if you go to Spotify and you search for Streambeats, it pops right up. There are 4 playlists that Harris has available, hundreds of songs that are now available for you to use. YouTube, Twitch, Facebook gaming, wherever you might be broadcasting. Free and easy for anybody to broadcast with. So, this is the Errata show. This is our 7th show together. If you click into the notebooks folder here, you'll see there are 7 notebooks at this point, and I've updated these each time with all the things that we've covered on each episode. So these are interactive notebooks that are built and are available to you if you want to use these. Maybe you want to give a session at your user group, at your meetup. You're welcome to download, use these notebooks, tune them if you'd like. You can even send pull requests with updates. But there's a magic button here, Launch Binder. You can click this, and it'll open these notebooks in your browser. You'll be able to execute C# code along with me, tinker, and interact with it live in the browser. There is also instructions here if you want to run these notebooks locally. You can download this repository and use Docker Compose to launch and get the notebooks running on your machine wherever you might be without having to connect out and interact. You don't have to install any .NET tools. You don't need to install any Python tools. Just takes a little bit of Docker magic here, and it will start everything up for you running locally in your browser wherever you might be. So let's get into the errata. There was a bunch of different questions that came through, a handful of different topics. I've even set up a project here to show here are the upcoming ideas, some upcoming show ideas. We're going to be talking about interfaces and abstract classes. It was labeled as September 28th. I took a week of holiday there. We're going to bump that to next week, but we're going to be talking about error handling. We're going to be doing a unit testing stream all this month, and I'm going to post an article out on the .NET blog. .NET, probably a Visual Studio blog. One of the two. I'm putting up a blog post with information about the upcoming streams. Now that we have 7 streams in the box, That's a pretty good playlist that you can check out over on YouTube and follow along and hopefully enjoy a little bit of this talk show type format. Of course, the AMA tag is on if you're watching us live on Twitch. You're welcome to ask any questions about C# along the way here, and we will pause, answer your questions appropriately, and you'll see them pop up over on the other side of the screen there with your message. We'll walk through and answer it, and of course, they're linked just below the video here on YouTube, so you can click and jump right to the question that you might have had if you want to review it from a previous episode, or if you want to see other questions that folks had. Maybe there's something there that you're considering, you want to know more about. You can check those out and jump right to that part of the video. How's it going there, Rick? Welcome in, Rick. Rick VD Bosch, I see there in chat. It's always important to me to greet the folks as they appear here on Twitch. So, we had these 6 questions that came in, 6 different things for us to talk about, and we're going to cover all of them in today's episode. So, I've already got the repository up and running here. This is running on my local machine, so I can be sure that we don't have any delays or anything while we're starting and running here. Let's talk about the errata review. Let's get into this. Let's talk about some of these questions that came up, some of these things that we may have missed, and tinker. Run some code here. Let's create some errors. Let's try some different things. These samples are built here so that they run, but nothing's keeping us from testing and trying something a little bit different. Now, if you open these notebooks, if you give this a try, I want you to do me a favor. Click some of the links that are inside the notebook here. There's links to official documentation here, and they actually have just a hint of tracking information to let folks know that you went to the documentation from this broadcast. It lets folks know, it lets us know that you're using the notebooks and that you're working through some of the samples. All right. Now, first thing that we didn't really talk about was way back in session 1. We were talking about, in session 1, interacting with various numbers, basic calculations, and we talked briefly about operators. And we got into the plus equals, minus equals, these, right, transform and assign operators, and that's nice, but we never got into the increment operator or decrement operator. So what are those, right? You may have seen me use the plus plus or minus minus operators. Pure and simple. You can use the plus plus before or after a variable, right? And it will either increment or decrement it before or after it returns that value. That sounds weird. So the first example I have here, if we set up a counter and we say that the value is 1, we can increment it by putting plus plus after the value. Now, because we say display counter plus plus, it's incrementing the value after it displays it. So we get the value 1 output first here. When we evaluate and we take a look at that counter variable after it's been incremented, you see it's the value 2. So it's been incremented after we've actually interacted with it, after this statement has concluded. We can turn that around and we can actually put the plus plus in front, and we'll increment it before displaying it, and we get the value 2. That kind of makes sense. We can do the same thing with the decrement operator. Change this to minus minus, and I'll control enter to have it execute here, and you see it's still 1, but it gets decremented down to the value 0. Is Karnak running? Do I have Karnak running? It should be showing you my keystrokes. Let me rerun Karnak so you can see my keystrokes pop up in the corner there. There you go. Now you can see my keystrokes. All right. So the same thing happens over here with the plus plus minus minus. I can change those back and forth, no problem, right? And this kind of makes sense. This is something that we didn't cover. I didn't explicitly cover, but it was something that was brought up and was shown in some of the past episodes, and I wanted to make sure that I properly showed this. Similarly, I never showed the negation operator. I never showed how to flip a Boolean value from true to false, right? How do you turn that test to not that value? And it's the exclamation point. Real easy. Var is true, display not is true, and you get the value false. Big deal, right? Similarly, we're going there next. Similarly, you can do things like display. I can say not 1 equals 2, right? The double equals is a test, not an assignment. Single equals is an assignment operator, but double equals, and yes, 1 does not equal 2, right? And I can also change that and do does not equal like that as well. So, a couple choices, right? I could say 1 greater than 2 is false, and I can make that invert it with the exclamation point up front. So, not too bad an issue. Oh my goodness! 55 Raiders from Professor A. Heil coming in. Hello, hello. Welcome in, Raiders. I'm going to pause for a second here and welcome in the Raiders that are joining us. So good to see you. Thank you for tuning in. Thank you, Professor A. Heil, for bringing in your folks. He's a member of the Live Coders team, and that's not the display I wanted to show. Where'd it go? There it is. My name is Jeff Fritz. This is the Visual Studio channel, and this is the Errata review episode. We're talking about all the various things that are kind of a little bit deeper dive topics, some things that we didn't cover during our basics episodes here on C#. And we're highlighting those, we're showing them off, and we're going to tinker with them here live in the browser using .NET Interactive and Jupyter Notebooks. What were you working on over there on your channel? Let us know. And we can talk about that briefly here. Pareka303 asks, I'm not going to put this up because this is a reference to a stream on my channel, asking how .NET 5 on Ubuntu went, how that went for me yesterday. I got things corrected. The install, there's a challenge with Ubuntu 20 where there's now the snap install system and there's the apt install and package management system. They don't install to the same place. So I ended up uninstalling with snap and installing .NET 5 with apt, and things started working well for me. Thank you so much for the question, Pareka303. Is that, oh my goodness, Masquerain Hasneil from Mumbai. Welcome in. I'm sure I'm not pronouncing that correctly. Let me know, and I'll make sure we pronounce it correctly going forward. So, welcome in, Raiders. Thank you so much for joining us. And I'm going to head back over, and we're going to talk about some of the next topic that I want to talk about. As we kind of go through some of these changes, some of the things that we missed it's talking about getting information about types. So, type of, get type, name of methods, ways that you can work with the actual types and even convert them to strings, so it actually looks good for interacting with messages you want to send to your end users. Professor A. Heil was doing some software engineering lectures. Nice. You know what? Twitch is a great place for education. It's a great place for us to discuss, interact, and I like continuing that and pushing that forward here with our friends from Microsoft on the Visual Studio channel. Really appreciate that, Rig. So these three, they're methods, they're expressions that you can use: type of, get type, and name of. So you use the type of expression to get a reference to a type based on the actual C# type that you pass in. In this case, I'm saying type of int, but there's nothing keeping me from changing that to maybe string, and I get system.string is returned, right? I get that as a type returned, right? It's a It sounds weird to say this, but it's an object called type that has a reference to, right, that defines a string type. Now, right, I can pass other things in here, like, right, like a, let's not put a list. Let's put, a hash set, right? See, there, I'm going to get this wrong, aren't I? Hash set, hash list. Why am I not remembering this? It's not a, I can do, not a, can I do a view bag? Is that still in there? No. Property bag. Am I going to have access to that one? No. I could do dictionary, right? Nah, requires 2 type arguments. Fine, I'll give it 2 type arguments. And now I get dictionary, right? So it's giving me this information, and I can further inspect that type and do things with it if I need to. So that's interesting if you know the type that you're passing in. Mascarenhas. Nice to meet you, Neil. Thanks so much. I got that cleared up in chat. But if you have, so this is good if you know the type that you're inspecting. You can say type of, and you can get that type at design time, right? At the time that you're writing code. But if you're interacting with a variable and you want to get the type of that variable, you can use the getType method, which hangs off of all objects in C#. So in this case, I defined an integer 5, and I can get that type reference by executing getType, and you see it's an int 32, right? Similarly here, if I say this is a new, let's do this with a list, a new list of type string, right? I'm using var, the var keyword that adapts and means that my int becomes whatever type is on the right side of the equal statement. Well, now it says that this is a list of type system string. Kind of makes sense that it knows and it adapts appropriately. Right, and I'll change that back to 5. And it's an int. Now, the last piece here that I want to talk about is a recently added feature. It's like C#7 called name of. It's here 6 or 7. If you're using .NET Core, if you're using .NET Standard, if you're using .NET 5, this feature is available to you. Name of lets you take a type object. So, right, we got system int 32 here, system int 32, we had dictionary there, but you can take either that type or a member of that type and return it as a string. So if you have a method name that you want to return and use that method name, ensure that it lines up properly so that we can define an error message, let's say, you can use name of to ensure that it turns that method name into a string appropriately. So let me scroll down and show you the example here. So here, it's not just method name, but members of an object. So that also goes for fields, properties, events, all of those things. You can use name of to output that as a string. So I can use name of with the class person, and it outputs the text person. Right, that's different from saying, right, display type of person, right? If I do that, right, it shows there's my person class, the person type. That's not, right, a string. Okay, so yeah, this is a little bit of type introspection. This is allowing us to inspect and get into that type a little bit further. Now, you can inspect the type, and you can particularly reach in and look at the members, the methods, or the fields, the properties, the events. You can do that type of inspection on that type, right? If I could reach into this person class and I could get the collection of properties out of it if I wanted to. And that dives into a topic called reflection. And reflection is something that I want to cover a different time because it can get a little bit tricky, and it gets into a little bit of theory as to how all of these features of C# and .NET are glued together. So for the purposes of being able to pass around types, because there are times when you want to inspect and get the type, or you want to output the name of a property or a method. You want to be able to turn these things into strings. And this is particularly important, and why I included it in this episode and why I put it in this notebook is because next time we're going to get into talking a little bit about object inheritance and error messages, error handling. These are going to be important topics that you're going to want to use when we get into that episode. See, that's called a little foreshadowing, right? That's selling the sizzle, getting you into the next episode. See what I'm doing? See that? See? I'm trying to get you set up and interested in the next episode. And of course, if you're watching this on YouTube, it'll be the next one on the playlist. Know what I'm saying? So, that's the thing. All right. So I don't want to get down into how the type introspection works, and the things that you can do with reflection in there. Just because I want to stay at a beginner level and just touch on, because there's also a couple other methods here where we're going to inspect the type and work with it, particularly around enumerations. We're going to see a little bit later. We didn't talk at all about string formatting. We talked about working with strings and passing them around in string type, but we didn't talk about formatting so much. So let's talk a little bit about formatting and some of the things that you can do with strings here. And one of the first things that you may have seen me do in a number of the other notebooks is concatenating. And the easiest, simplest way is to concatenate with the plus operator. If both sides of the plus operator are strings, it puts them together and returns a new string that is the contents of both stitched together. Now, strings are a reference type, so this means that it's creating a new reference type and returning that to you with the contents of the two stuck together. And eventually the garbage collector will come through and reclaim those two objects, those two string objects that were glued together, assuming they're no longer in use. So I can do things like greeting equals hello, display greeting plus world, and of course I'll get hello world, and I can also do that with plus equals, greeting plus equals C# developers, and I get hello C# developers. So hey Ed, we're not looking at Blazor today. No. This is just getting started with C#. Now, this is very simple, but in high numbers, at scale, we call it, when you're doing lots of these per second, per processor on a machine, it's not terribly performant. You're going to run into a lot of memory reclaiming issues because it's allocating more memory for you. Another way to combine multiple strings is to use concat. You can also use join. You can also use format. So concat, we can say string.concat and pass it a comma-separated set of parameters that we want it to stitch together, and it will appropriately manage the memory for that. No, Lissamet, you don't need glasses like this. So concat, I execute this, and I'll get the greeting good, and time, I have this calculating, and if it's a certain time of day, wherever you might be when this executes, it specifies a certain time, and I put the name Fritz here, so it stitches that together. So I can make this whatever, and it stitches it together, and it gives me the string. No big deal. So concat is a little bit more efficient way to do this. Now, we can also do that with an array using a join command. Now, string.join will take whatever the entries are in that array. In this case, I grab the variables from up here, greeting, time, and name, and I'm joining them together. In this case, I'm putting a space in between them. But you might have data you want to put into a comma-separated value list. You may want to join and separate with whatever character it might be. Maybe you like tabs. I like tabs in my code, in my notation. You put that in there as, here's the string that I'd like to use to separate these values in the array. String join and pass in the array, and I get the exact same thing being output here. There it is. Not bad, right? That's pretty easy to interact with, pretty easy to understand. Join operator, you want to turn a collection of and these are particularly strings. I could certainly turn these into numbers and do that join, and now I get those numbers. Now, those are no longer numbers. Those are now strings, right? This is a string that was output, right? So if I use, going back to what we learned earlier, if I use get type there, you see it outputs a string. It's not a collection of strings. It's one string. And it's those values stitched together. So, how we doing there, chat room? I see a couple of folks talking to each other, some jokes. I'm going to give it a second there, a second or two, in case anybody has a question they want to type in. Otherwise, we're going to move through this really quickly. How am I doing? Not bad. First day back. First day back from a week off, and feeling all right. All right. So, string join. Let's talk about formatting. Right? Formatting, it gets a little bit more interesting. Now, the original way in C# that we would format strings was to use these positional indicators in a template. So you just have a string, right? In this case, I would say good, and you provide zero-based indexed these little tags of where you want to put content inside of it. Now, you then use that format string with this string.format statement. It'll take in that format string and it will place these arguments appropriatly wherever the zeroth tag is and the first tag is. And you can have this go out to any number. It probably stops at like 256. But you can use this formatting and it will apply appropriately. And I can actually reuse tags as well in here. And it will repeat those appropriately because that's my template, right? If you try to put a tag in here that has not been allocated, you get an error. It doesn't know what to do with number 2. It doesn't know what to place in that third tag there. So, pretty straightforward, pretty easy to see how that works. But this is also a little bit annoying, because if I have a string that I want to format and I'm trying to, as a human, look at this and stitch that back together, right? Now I've got to, okay, the 0th one, well, that goes over here, and this goes up in there. And what happens if I turn these around and I put them in the wrong order, right? Well, now, right, my human mind looks at this and I need to figure out and put them in the appropriate order, and it can be a little confusing. So there's a feature that was introduced in C# 7 and later called string interpolation. And you've seen this probably in some other programming languages, particularly JavaScript has this, where I can prefix, right? The syntax for C# is I prefix my string with a $sign. And I can use those tags, but instead of putting a number, as soon as I use a curly brace here, everything inside of the curly brace is now a C# expression. So I'm going to output the variable time, and I'll output the variable name. Now it's crystal clear to me exactly what's happening inside that string formatting operation, right? I can right? I can even use, right, like I said, it's an expression. I don't just have to put a variable in there. I can put a method call in here, right? And it outputs those things appropriately. And this is where it becomes a little bit interesting, right, for when we want to build error messages. If I want to build an error message and reference a particular object by using it this way, if something happens in my person object, well, if this changes names, right? Well, now all of these things need to change so that it continues working. But if I go down here, where I have that name of, here, now how'd that still work when I removed, if I rerun everything, it still has something in memory. It didn't actually reclaim. Here, this won't work. There it goes. Now I get the error. Person does not exist because I changed the name of the class. So you get a compiler error here if something happens and you change the name of your class because I used name of instead of person. I'll pause here. I see a question in the chat room. Let's make sure we answer this. Lazy Invader asks, are anonymous functions possible there as well? Absolutely. You can do expression bodied members there. So, right, I could do something here that says, no. Right, right, I can actually have it. This is going to be kind of weird because I'm not passing in a value. Right, I mean, I'm executing any kind of a method here. So, if I put up here, where did that people class go now? People, right? If I put a method on here, public int calculate age, return, right? Datetime dot now dot subtract new date time 2000. And that's actually not good. That's going to be a time span, isn't it? Right, so I could put in here, what did I name the person up top there? I just had it. Right, Fritz. I could say Fritz dot calculate age inside of here. I didn't execute it. I need to execute this first. There it goes. And down here, re-execute this. And now I get the number of days since January 1st, 2000. Curious Drive follows up and asks, well, could you do a for each inside of here? You could, but it's going to get a little, you need to return a string from this. That for each isn't going to return a string. For each returns a void. So I wouldn't do that, right? You could do perhaps a collection select, right? So if I have a collection of names, right? So if I have Fritz, Scott, Maria, Jamie, and I could do, right? If I just put names in there, it says, right, system string. I could do string.join. I can do that, and it formats those. But if these were objects, right? I could do a .select method on there and return just specific properties of that if I wanted, and do a join to format it like this. These are possibilities. Yes, great comment there from Chris C 119. There is you can do this, and there is you should do this. Putting a lot of logic inside of a string that's being formatted there is messy, right? Suddenly you've got some logic that's being built here that, right, string join isn't too bad, but if you start doing some other method calls and things in there that are doing more complex formatting, it's going to get messy, and it's going to become trickier for our human eyes to be able to discern what's going on. Yeah, debugging this is going to get a little messy. So, putting queries in the middle of formatting. Now, this is a little bit of formatting. We did concat earlier. Another technique that you can use is to use a string builder. Now, a string builder is an object that behind the scenes concatenates things for you and manages that memory in a much cleaner way, much better performance. So I can create a string builder object here. I usually name my string builder variables SB, right? String builder, because I don't allocate many of these, right? I'll allocate one in a method, and I start putting together the various parts of it. You can use append format as one method on it, so you can append using that same string format syntax that we saw up here, and it will append whatever is this value out here. I'm appending space and then append a name, and you can get the output of all of that jammed together by executing the toString method, and the string builder will do that concatenation for you. So, not bad, and an easy way for us to be able to see, here's how I'm putting these together, especially if you have methods that you're running in between each one of these statements where you're doing calculations, maybe you're fetching data from a database, and you're appending, you're building what that string is going to look like. String Builder is a very efficient way to do that interaction. And, right, when you think about building web pages, building script that you may hand off to JavaScript, right? Executing all of that formatting for how you want your HTML to look. String builders are really a little bit of the foundation of how that works. Let's jam those together in a way that is clean and easy for folks to see. Here's how we assemble those, and the string builder manages memory appropriately behind the scenes. Good morning, Dave. Welcome in. Hello. Now, we've put together strings here. What if we want to separate strings? So the next bit that we didn't really cover is about splitting strings. So if I have a string with some common separator character, I can break that up into an array. And I did this once or twice in several of the previous notebooks by using the split method that's available on all strings. So I've declared a phrase, "Good morning, Cleveland." I really should say that with a little bit of an echo. Good morning, Cleveland. Hello? I don't think anybody from Cleveland's here. Sorry. John Calloway, good morning to you. So I can split that on the space, right? There's spaces in between there. So split that, turn that into 3 strings, because there's 2 spaces in this string, and it turns it into an array, and you see I get 3 items in the array. Good morning and Cleveland. And I can particularly grab, right? I can, if I wanted to grab just, right, whatever that city is there, Why didn't it grab Cleveland? Oh, I didn't. Okay, hang on. I didn't assign that value anywhere. There it is. Now I get the value Cleveland. So, right, maybe I don't know what that is at the end there. Right, maybe it's Seattle, and it'll grab whatever that last bit is, and now I've got it available to me. I'm going to change that back to Cleveland just because I think Cleveland sounds funnier. Wrong continent? Okay. All right, fine. Good morning, Madrid. How's that? Good morning, Rio. Whatever, right? Take your pick. I put a capital on Tokyo. There we go. So, you get the idea. It's a simple example that we're showing here. Now, something that I didn't show, and actually I don't think I have an entry here for it, is about string literals. So you actually saw, if I put a new line in there, it doesn't know what to do with it. Also, if I want to put a quote, right? If I want to use a quote indicator in here, right? Well, that's kind of weird. I have to start double quoting in order to get that to work, and this is kind of weird, right? How does that work? Well, you can escape quotes with a backslash character, and that'll work. But if you do want to use double quote notation instead of backslashes, right? You can put an @ sign in the front, and it will take that as a literal if I remembered how to do this properly. Why didn't it do that properly? New line and constant. Where? Where's it seeing that? I've got an extra quote there. That's what it was. There it is. Yeah. So now that @ sign says even things like character returns are acceptable. So I could do things like this, and instead of having it split on an empty space, I could have it split on the new line character. \n is the new line character, and I get it splitting on the new line there if I'd like, by using the @ sign in front, right? So those are just some of the games that you can play with putting together strings like that. Let me get rid of the quotes. There it is. Now, I've put together, right? You can do this with strings if you want to do comma-separated values. Yes, there is environment new line as well. Yep. You could do split with multiple characters. Yes, things I didn't want to get too far down into. Right, I'm not going deep on many of these topics. It's more to get a breadth, give you pointers to the different places where if you want to learn more about it. I forgot to put a link in here to the split documentation. I'll have to go back and do that. If you split on things that look like numbers, those are converted, those are still strings. It doesn't convert those to numbers. Okay? Even though it looks like a collection of numbers. Looks like the machine, the compiler, sees those as strings. So, if you want to convert and use those as numbers, you're going to need to convert them back somehow. Cast them back to an integer. So, yes, that is Jupyter Notebooks formatting it appropriately, an array as a table for us. It has that display formatter available for us. Environment new line, you certainly can use that. There was a comment about that. So if I change this Do like that. Instead of splitting on space, there is environment. Is it new line like that? There it is. Now, it should have, no. It should have picked up. And it's not. I have a feeling this is part of the .NET Interactive interpreter, that it isn't seeing that properly. Change that over and it does work using the /n. Alright, I'll roll that back. So these are the things about strings that I didn't quite cover. Like I said, you can go deeper on these. There are additional topics that on string formatting. I could spend a whole session on regular expressions, and my security officer would prefer probably that I didn't, because regular expressions by their nature are easy for folks to create a little bit of a security problem with. So we recommend folks avoid using regular expressions directly with user input. Something to be aware of. But there are regular expressions available. They work very similar to regular expressions in other languages and other frameworks that you may have used. I'm not covering them right now. I want to make sure I get appropriate capabilities around that. Yeah, regex is a write-only language. Oh, yes. Yes, yes. All right. We talked about enums back in, I believe it was episode 3, right? Episode 3? Yeah, session 3. And we use the enum keyword to represent some related values, but there's some things that you need to know about enumeration types that are kind of important, that you may want to use to get values, get user input into an enum, get it out of that value, and inspect and work with the type, so that you might be able to do some important things for your project. So what if we want to convert data, right? Maybe you saved some data into a spreadsheet, into a database, into a file, and you want to convert it back into that enum type. Well, enum types, they're an extension of numeric types, and typically it's an integer. You can also have it inherit from other numeric types. Maybe you want to inherit from a byte. You put colon space byte. You can inherit from short. But you define this, and we can assign whatever values we'd like to our type, to our constants that we want to declare here. I don't have to be 1, 2, 3. I can make C# 100, and it will behave appropriately, and I can convert and cast back and forth using my regular cast operators, right? Inside parentheses and the type I want to cast to. So I'm referencing C# here, display whatever my language is, and output C#. I'll even just re-execute that. Convert it into a byte, even though it's the value C# here, and we've said C#, cast it back into a byte and I get 100. Cast it back into an int and I still get 100. And I can push values back in. So if I stored the number 2 in a file or in a database somewhere and I want to turn it back into Visual Basic, right? I tell it to cast, right? Inside the parentheses, .NET languages is the type I want to turn that 2 into, and it becomes Visual Basic now, and it'll work appropriately when I do tests for .NET languages Visual Basic. So, yes, it's me. It's CSharpFritz. How you doing there, Jai Maru? Welcome in. Of course. Running things here on the Visual Studio channel, having a good time. Now, you'll also notice these values don't need to be in numeric order when you declare your enum. They're in whatever order, and it's fine. It works just fine like that. Let me touch on this question. This is kind of a bookkeeping type of question. Are these sessions on the Visual Studio channel on YouTube? These are on the .NET channel on YouTube. So if we go youtube.com/.net, and there's some upcoming live streams on YouTube. We do not broadcast on YouTube, but if you go over to playlists, you will see Learn C# with CSharpFritz. And there's the playlist. So every one of these has a full set of questions underneath and links to all the source code, all the material, so you can follow up. Thank you for the question. Yep, this is episode 7. How you doing there, Wild Genie? All right. So this is great when you're dealing with the numbers. If I'm dealing with the strings, right, the names of these various elements, the constants inside of my enumeration, you can get those values and, right, I mean, I've returned the value here, but I can push a string back in and convert it back into that enumerable type, that enum type, using the parse and try parse method. So check this out, right? I can say this language equals C#, and if I say enum.parse, and I can use the generic format of this inside of angle brackets, pass in, well, I want to convert this to a .NET languages type, and I want to convert this language, that string, C#, and tell me what you find, and that turns into C#, right? It knows what that is. I can put get type here, and it's a .NET language type, right? That's appropriately what it should be. Now, I can also pass a flag to tell it whether to ignore right, to make this case insensitive. Ignore the casing of it, turn it back into whatever. So if I spell C# appropriately, capital C, capital S, it'll turn it back into the type here when I have that set to true. If I don't provide that flag, it's case sensitive. It comes back, right? Similarly, it defaults to false. So if I put false in there, it throws that error. So now this is not WordPress that we're using. This is Jupyter Notebooks. WordPress does work on .NET Core, but that's different. Yeah, there was another show about that over on the YouTube channel. Now there's a try parse method that has a very similar signature that will return a Boolean to indicate success, and it returns an out value here of whatever it is that you're parsing. So out my language, and display and show. So if I'm passing in Visual Basic, capital V, capital B, which is not the way that it is in my enum type up here, it will parse that. True, it successfully parsed it, and it's Visual Basic. But if I turn off and make this case sensitive and rerun it, notice my language is 0. It doesn't have a value. It didn't find anything. And false, it was not successful in parsing Visual Basic. So this is a nice way for you to interact and test appropriately to figure out, is this an appropriate value before you start trying to work with it, right? Prevent an error before it possibly happens. No, Thindall. So Thindall is actually referencing a new feature of the language. Why isn't it showing? There it is. Do you need to do out var my language? So what Thindall is referencing here is this out parameter that I have here. I can actually create that variable on the fly. My language is defined up higher in the notebook. This variable is already defined for me in the notebook. in this block, I can make that, you know, whatever I'd like to be here. I can define, you know, out var, and I can call this whatever I'd like here, right? Fritz language, right? I don't know. I'm just going to name it after myself because I'm egotistical like that. And I execute it again, and it's allocated, it's created the Fritz language variable on the fly for me here. If I didn't use var there, I've already allocated it. Fritz language is now declared, it's available. Where if I call this foo, well, foo doesn't exist. There we go. So that's different, right? This is, you need to actually declare and make this thing available here, right? So I use out var, and it declares and allocates that object for me on the fly. The way that Jupyter Notebooks work, it doesn't actually destroy these objects behind the scenes until I restart the kernel, until I restart the C# kernel behind the scenes. When it does that, it parses everything all over again, and now it'll give me foo here, right? So there it is. It doesn't actually clean up older sessions. It doesn't destroy them. You need to restart in order for it to go. So, all right. Now, what if we want to look at those values inside the enum? Well, you can execute get values, enum get values, and pass it that type, and it will return to you, here are those values. Now, but it's the constant values, it's the integers that it's returned for the purposes of putting together maybe a combo box on a user interface. This isn't very useful when you might want folks to be able to select C#, Visual Basic, F#. So you can then go back and use a for each statement like here and actually cast it back, saying .NET languages, right? Cast it to that type, and it returns this. Now, this is an array it returns, right? If you look at this, it's an array of .NET languages. So we can't do a .select on this. That's a link feature that doesn't wire up here, right? Select, we saw in our link session last time, right? We could do things like this, right? I can't do, right? That doesn't work because that's an array coming back. It's not an array of type T or a list of type T, right? I might be able to do, right, that, and it still doesn't do it. You're going to run into issues here trying to cast it into a generic type and interact with it. So I just did a quick for each here to get those values output. Now, continuing on, the big question, the really big question that folks have and C# developers run into is, when and how do I use a struct? In episodes 2 and 3, we talked about the class keyword and defining class objects. A class is a reference type that allows you to define fields, properties, events, methods, classes inside of classes, enums inside of classes, delegates inside of classes, that provide a natural grouping level for a set of related features, and we think of those as objects. And they get very complex, but it's a reference type, meaning that when you allocate those, when you create a new class, it's stored in a place in memory called the heap. Now, the heap has a garbage collector that runs against it every now and again. You don't typically control when it runs. There are ways to work around that, as with everything in programming. But that heap has a garbage collector that sifts through it, finds those non-allocated, non-used objects, and reclaims the memory from them occasionally. But when it does that, It pauses things. There's a brief pause while it frees up memory, and you don't have control over that. So in high performance scenarios where you have small value type objects, it's valuable to use a structure value type. And value types are things like we saw in our first session, things like numeric types, integers, shorts, bytes, doubles, floats, decimals, booleans, not strings, character types. These are all value types by default that ship with C#. If you want to create your own value type, your own type that we can reclaim and use quickly, right? That value types get allocated to the stack. And when objects are no longer used on the stack, they're reclaimed very quickly. They use much less memory, and you don't have the garbage collector come through and freeze the system while it's going and removing all of those objects from memory. So sometimes it makes sense to use value types. Now, a struct has a couple of constraints in order for it to be a value type, in order for it to provide that quick memory interaction. A struct needs to have a constructor defined that configures all the properties, all the fields inside of the object. You're not allowed to create a struct without a parameter, with a parameterless constructor. All the fields and properties cannot be assigned as they're being declared. You must instantiate them. You must assign their values either in the constructor or later on. Finalizers, and we haven't talked about finalizers, we haven't talked about dispose method, those a little bit of class design that's going to come later this month. Finalizers are not allowed. A struct can inherit from another type, cannot inherit from another type, but can implement interfaces. And we're going to talk about abstract classes and interfaces next time. So if we want to store some related numeric types, this is typically where you'll see structs being used. You can define those and get that related type so that this can be allocated and made available as a unit. You'll see things like coordinates. Coordinates are a perfect value type because you have X, Y, Z, depending on how many dimensions your coordinates are going to cover, X, Y, Z numbers that are related, and we want to be able to reclaim those quickly. So we create a struct for coordinates. This is a good question from Lazy Invader. Does this also apply for really big structs? Can a struct be bigger than the stack? Well, the stack is allocated appropriately. We recommend in our documentation that you keep your structs smaller than 16 bytes. Rules are meant to be bent. Some rules are meant to be broken. You don't want to make these things very large, otherwise you're messing with how you're going to be messing with how memory is allocated and works in your application, and it could have unintended consequences because you're allocating so much memory onto the stack. You don't want to do that. Keep these things small and keep them clear of what they're doing. Try and keep them as tight as possible so that you get that very quick memory interaction. You can make it very big, but I would discourage you from doing that. Spot Tigus says, I think of the example of points, coordinates, being a struct because you might have millions or even billions of coordinates. Yes, right? If you think about trying to plot a graph, you might have thousands, millions, billions of entries in your graph. You want to have that laid out quickly. And when that graph goes away, you want to have it reclaimed very, very quickly. You don't want to have it analyze and collect them. It's very small, and have it pulled off the stack as soon as it's no longer being used. So I created a simple example here of a struct called a rectangle. A rectangle has two dimensions, length and width, and I have to create length and width in my constructor. I've allocated them to the length and width properties, And I've also added several read-only properties for the area of my rectangle, and that should be perimeter of my rectangle. And when I execute a new rectangle of size 2 by 5, I get it appropriately here, reporting the properties of my rectangle. 2 by 5, it has an area of 10 and a perimeter of 14. You cannot create a parameterless constructor here. You must have parameters, and it must be fully assigned before control is returned to the caller. So I can't have this, right? Is it gonna let me? Nope, can't do that. Right. Similarly, if I comment this out, it's not assigned. There's no value to that, right? I need to have a value in all of the properties before it can be returned. So this is, right? This makes sense. I'm allocating a new rectangle. It's a new value type. It's a new object. I'm passing the value of a rectangle around. You don't have a rectangle that doesn't have a length. In order for a rectangle to be a rectangle, it must have both a length and a width. And that's the way that you need to think about interacting with struct objects. So it kind of makes sense, right? Similarly, I can't do that. You can't do the initializer there in the middle of the property. That doesn't work either. However, I could define a static oops. And you can do that. That static object is available, and statics, right, are available for all instances of the rectangle. I need to cover statics in that next session. You know what, and I think we've got plenty of time here. I think I'm going to get into constants here as well. Wait, maybe I do statics and constants here. I can make this a constant with the const keyword, and it's always the value 5. Anytime that I interact with any rectangle, the depth is 5, right? So I can say display my rectangle depth. Oh. Like that, and now I get 5. Because it's a constant on the rectangle object. When I'm inside here, I can reference depth directly. Outside of it, I need to reference it by the type. And a constant is nothing more than a static value. It's actually a static read-only value that is defined at compile time. Static and read-only with compile time, right? The design time defined values like 5 is the same as static read-only. Static read-only, though, gives me the ability to say, well, I can actually execute this at start time, right? At the time that it's first referenced. So I could say date time now minute, and now depth is calculated and it cannot be changed. It's always set, and it's defined, it's initialized with the current minute. Can it draw it? No. There are no features to draw that. I would have to enable that kind of method and drawing rendering in another class that knows how to do interactions with the screen or the browser. See a couple questions here. Let me pause and take these questions. When should we expect to have a discussion on the C# 9 features? C# 9 is the next version of C#. There's a couple of new features there, a significant number of new features, to be frank. I am not going to cover the new features of C# 9 until after it is released. I want to make sure that you know the features that you're using here are fully supported, and until that is released, I won't cover it, so we'll probably do this the week after .NET Conf in November, and we may even have a guest help us out with that. But C# 9 features we will talk about, and we'll get into when they're available, when they're publicly accessible, and fully supported. And they're not yet. It's still being worked on. Nick, the first one, has a similar question, and this is a question about C# 9. So I'm not going to dig too far into this. This is more of a discussion. Introducing the init keyword. Could that possibly change the need of a constructor? There's reasons to use both. And we'll discuss, I'm not going to get into it now. There's reasons why you may want to use both. We'll get into this when we have our C# 9 episode in November. Let's get folks up to speed on all the other features of C#, and get them started and available with it now. You can take a look at the C# 9 specification to see information about the init feature. Now, the question, now that I've defined what a rectangle is, the question that comes up is, in seasoned developers, C# experts have this discussion all the time. When should I use a struct instead of a class? How do you decide? There are several guidelines, and I've linked that documentation here on docsmicrosoft.com. You can go through and read. There's all kinds of discussion here about memory allocation and how you interact with the type. I'm going to break it down and make it real simple. There's five points to discuss. If your object that you're creating is going to be small and short-lived in memory, make a struct. If it's going to represent a single value, all of the properties must be present for that object in order for it to be a valid object, because it's a single value comprised of those child properties or fields. Make it a struct. If you can allocate it in 16 bytes or less, so up here, when these were integers, we broke kind of outside of it. These should probably be bytes, and they'll fit in nicely. Make it a struct. If it's not going to be changed, if the value that you're storing is going to be immutable, right? You're going to just allocate a new one if you need to interact with and make changes to it. Make it a struct. If you're not going to be converting it into a class, if you're not going to take that value, put it into a class, this is the boxing unboxing discussion. Because boxing unboxing means, and we talked about value types versus reference types. This is, to simplify, taking things from the stack and putting it on the heap. Taking something from the heap and putting it on the stack. That's actually an expensive operation. You don't want to do that frequently. If you're going to be boxing and unboxing, taking something from a value type into a reference type, don't make it a struct. Make it a class. All right. Yes, links are not available here on the Visual Studio channel. We've had too many trolls come through and use the feature inappropriately. Sorry about that. So, all right. Spotagus with a follow-up question here. If you were to put a list of type int inside of your struct, what's it do? Does it deallocate and then collect? What goes on there? So, first off, if you put a list of type int inside of your struct, you've lost, right, all of the performance gain that you wanted in there, right? So if I have public list and right, and we call this I'm just just allocating something for the purposes of this. And we say Fibonacci equals new list int 1 1 2 3 5. Let's stop there, right? You can do it, but this is a reference type, and the way it references, allocates, and deallocates, yes, it's going to, when this object is no longer available, right, it's going to dump that list and then reclaim, and that's going to take time because now you've got pointers from the stack to the heap, and so it needs to wait for that heap to be reclaimed before the stack can be wiped. It's right, it's an issue that you're going to run into if you try and mix and match. You're absolutely right, Curious Drive. Structs do have limitations. So where and why would you do this? There was a great example earlier of plotting a graph. Those coordinates you plot on the graph, make those structs so they get reclaimed quickly. Right? When you tear down that graph and you deallocate it, if those were in memory, it would have to wait for the garbage collector to clean those up, versus as soon as that graph is no longer referenced, boom, they're gone. So phone numbers, that's a good one. And Nick, the first one, suggesting phone numbers. Sure, right? A phone number is a perfect example of a struct, right? If we let's allocate a phone number here, right? So phone number, right? Let's define this. So right, public phone number, and it's funny, it's going to be strings, which they themselves are reference types. Right, country code, string exchange number, public string exchange, and public string number, right? And I would say this country code equals country code, this exchange equals like that. In the States, we have area codes as well. Right? So, Jenny's number equals new phone number 1-867 5309. Display Jenny's number. And now I'm showing just how old I am. So, country code could be an enum. You're right. You're right. Sure. We could make this an enum. We can make this, right, to just evolve the sample a little bit, right? I went one too high. There it is. Enum. Country code. Right, I could do like that. And I could make this country code USA. Sure. Right. So, different ways that you can interact with this and build that out. Doable. All doable things. And, right, this is clearly an example where these are things that you want to allocate quickly and clear out quickly. So, there's other gimmicks, there's other tricks that folks, particularly as they built the .NET framework, .NET Core base class library, there's tricks that folks have used where they've built structs to be able to interact with types, base types, so that it runs much faster without having to allocate and garbage collect and possibly pause things. You see this a little bit in the source code, and you're welcome to review the source code for Kestrel, the .NET web server, right? It uses some other in-memory tricks, but it also uses a lot of structs, a lot of value types, so that it appropriately reclaims the memory from a request as soon as that request is gone. A web server request has completed being processed. Release all the memory as soon as it's done. Don't wait for a garbage collector to come along and reclaim things. Immediately wipe it out. Forget about it. That request is done. We don't need to remember it anymore. We've logged data to disk appropriately for our web server logs, but forget about it and move on. Those types of interactions are a great example of this. And you might have some big math, some processing, data processing that you may want to do, that you want to release memory as soon as it's done processing, interacting with these things. Structs are a good way to pass around that data so that it stays as small as possible and is freed as soon as you are done processing it. Key value pair that you use on dictionaries. Is key value pair a struct? You've got me thinking, is key value pair a struct? Go over here. Oh, key value pair. It's a class. But the key value pair generic is a struct. So when you use a generic dictionary, that is freed up. Yes. There you go. Thank you for pointing that out, Nick, the first one. Appreciate it. All right. So the next piece. So there's, and this is a big discussion point. And, you know, check out that other article with more information about why you would choose one versus the other. But I like to reference these 5, not those 5, where is it? These 5 reasons why you might want to use a struct. Now, we covered looping in session 4, but we never talked about break and continue keywords. We never talked about stopping and starting. You can, of course, stop a loop immediately by using the break keyword. So if I set up this loop for var I equals 1, this is a really big number here, right? If we break this up, for I less than 10 million, run this. But as soon as I mod 10, as soon as the remainder of I divided by 10 is 0, stop, right? And it will count to 10. We can tell it to continue by using the continue keyword, and it will immediately trigger the next instance of the loop. And this works not just in for loops, but also in while and do loops. You can use this technique as well. So if in this case I'm using the exact same setup, and I'm gonna, right, you know, we'll make this 10 million also. You can use these underscores in between numbers, numeric literals, to place wherever you might have a thousands separator, right? This is strictly a humanize feature using the underscores in there. But when I divided by 3 has no remainder, continue. Skip this iteration and continue processing. But once I divided by 10 has no remainder, stop. Break out of the loop. And if we execute this, you see I get 1, 2. It didn't execute 3 because it told it to continue. Skip this iteration. So it just kept right on continuing. So same thing with 6 is missing, and so is 9, because those are multiples of 3. This is kind of a very simple keyword that we did miss in our previous session, and I wanted to make sure that I covered it here for completeness. Right? That's a word, completeness. So, now, I believe it's the final topic that I have in here. We worked with collections over the last 2 sessions, and we never talked about initializing them. So you can initialize an array, of course, with the curly braces. New collection of integers, a new array of integers, Fibonacci, 1, 1, 2, 3, 5, 8, 13. And display that, and we get that array being output, and there it is. But you can also do this initialization with the curly braces for the list and dictionary types. So this is very handy if you've got a base type, a base list, or a base dictionary that you want to load up. So I can create a list here of type string, and I can load it up by curly braces, and I put my values inside of it. C#, Visual Basic, F#. And I can even declare those appropriately as some other type right here as well. So, right, I don't have to write in there C#, Visual Basic, F#. I can certainly add, right, write my shapes. I can make this a new list of type rectangles, right? And each one of these are rectangles in here. So I believe I can do it like this, and I believe I can just use the new keyword with these, right? Forgot the... No, target typed object is in preview and unsupported. Ah, rats. So we actually have to specify this. This is a problem with the interpreter being used by Jupyter Notebooks. So I'm just going to copy and explicitly say new rectangle. Where am I missing? For my shapes equals new list. Line 8. Display my list. New list rectangle. Da, 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 da. Oh, I forgot the equals. Silly. There it is. Right. And if I display my shapes, there they are. Notice I still have that Fibonacci constant that's available in all of them. Oh my gosh, we have a raid from Copper Beardy. Welcome in, friends. Hello, hello. So good to see you. Yeah, I forgot the equal sign. Thank you for joining us. Hey, how's it going there, Copper Beardy? What were you doing over there on your channel? Let us know. Make sure you check out Copper Beardy. He's a good friend and a member of the Live Coders team. My name is Jeff Fritz, and we're talking about, we're filling in the gaps on some C# features that we missed in our previous 6 episodes together. So this is a nice way to initialize, and we do this also with a dictionary, and we can specify new dictionary, and we have our key value pairs. And a key value pair you can initialize inside of curly braces there as well. Yeah, the new without the type, it's a preview feature that isn't supported in the notebook, but this will work if you do this inside of an application. It's just not available with the interpreter that we're using here on the .NET Interactive Interpreter. The preview features aren't turned on. So... all right, I believe that's the end of this notebook. We've got some time left here. I'm gonna pause and see if we have any questions that we want to come back to there in the chat room. I covered a lot. I scattershot covered things across all of the different notebooks, all of the various sessions that we had covered up to this point. I'm going to make sure that we drop chapter markers on the YouTube video so you can jump right into each one of the updates that we had here. And I'll be editing and releasing this video later today on YouTube. Yes, the notebook is shared. If you go to the GitHub repository, you'll be able to click through, you'll see the notebooks folder here, and you can click the launch binder button here, and it will launch and give you that Jupyter notebook inside of your browser, no matter where you might be. You could be on your phone, you could be on a tablet, and it'll start and you'll be able to see exactly those notebooks running in the browser. So, you'll also see inside that GitHub repository, you'll see where we're going to plan and build out the next sets of episodes that we're going to get into together here on stream. But next time we're going to talk about interfaces, abstract classes. We'll talk about virtual methods, abstract methods, and we're going to get into error handler. Yes, the previous sessions are available on the YouTube channel. If you go to youtube.com/.net, you'll see in the playlists there is a C# with CSharpFritz playlist there, and you'll be able to get into it. There you go. There's the notebooks running in the browser from Binder, and you can click into any one of these, tinker with it, interact with it, run the .NET code however you'd like. These will all run for you, and you'll see exactly how they operate. So that's right, leave it, and there's episode 107. So there we go. There's today's the base notebook. It doesn't have the edits that I've been doing along the way here, but this is where it started before we started our session together today. So I'll quit so it properly deallocates that. I see a question there from L. Lehman in chat. Let me see here. So let's put this up. New to C# and recently came across the new int, comma, declaration. Thought it was a typo and realized, yes, that's a multi-dimensional array. So if I go back up here, I declared an array like this. I can effectively declare coordinates, right? Equals new int with a comma like that. Now I've got it. This is a two-dimensional array, and I can start declaring a series of coordinates. Let's comment this out. Now, why did it only give me the one dimension? Not sure about that. It should have given me each one of those as... Right, it didn't... Right, if I say coordinate 0... Yes, it's multiple indices. There you go. So it finds it appropriate across it. That looks like an issue with the display formatter. Huh. That's not right at all. That's definitely an issue with the display formatter here in the notebook. But, yes, you can declare multi-dimensional arrays. Have a good one, Neil. Thank you so much for stopping in. Lily Hazel is here. How are you doing, my friend? Good to see you. Hello, hello. Taking a look here. So I did talk briefly. I've got about 15 minutes left with you. Maybe we'll make it 10 because I have an 11 o'clock. I did talk briefly about constants and static. So, constant static keywords. And I'll make sure I build out this part of documentation. Right? So, a constant is a non-changing value, right? So we can say const int 5 equals 5, right? Which, that's kind of weird, right? But I can say display 5 and it gives me that. I can't change that value. It is a constant. I can't say 5 equals 6. That doesn't work. You can't assign to a constant like that. But I can, right, that constant is now available wherever. And constants, it can be declared inside of a class. Right, let me get rid of that. Can be declared inside of a class so that I can do things with them later, right? So if I create a class here, I'll call this one person, right? No, you know what? Let's call this, let's put together a class of, not person. What can we do? Student. Sure. And I can, that's not, I can declare a constant, that is, maybe it's an int, and it is, now, what would be a good constant for a student? Thinking. Maybe I have a bool enrolled equals true. They're always enrolled. That's a bad constant. Oh, there you go. Max GPA. That's a good one. Right? That's always going to be a thing there. So I can say decimal max GPA equals 5.0. Right? Now, without an accessor declared there, it's by default privately accessible. Nothing outside of the student class can interact with it, right? If I say display student max GPA, right? Oh, you make me sad. Right, it's inaccessible. It's not available. So I need to make this either public or internal, and it'll be available outside of there. Date of birth is not a constant. Now, conversely, there is the concept of static. And static is, while a constant is a variable, is a value that's associated with the student type. A static, it can be a property, can be a field, can be a method that's associated with the student type as well. So if I, let's start another here. So if I have let's create a class student, right? And if I have a public static, right? So something that's associated with all students, right? And this could be, in class, right? All students are in class, right? And this is a Boolean, and by default the value is false. So now I can have a bunch of different students here, right? So let's create the class is a bad example. Students equals new. We'll make this a student array. Let's put a name on our students also. And each student has their own name, right? So I'll have new students. I see Hugo there. We'll create Hugo. New student. Name equals Fritz. I saw Lily there earlier. New student. Name equals Lily. There we go. So if I display students, right? Hugo, Fritz, and Lily. But I can go through and nobody's in class, but when class starts, I can say student.inClass equals true. And if I see, it's not showing the in class there. Let's put a toString on this. And we'll return a value here. We'll say name and in class. It's still not going to display it, is it? No. I should do a ForEach to display those, shouldn't I? In students, s to string. Capitalization shoe. There we go. So now everybody's in class. I should probably put that same ForEach up here. Nobody's in class. Everybody's in class after I set the in class to true. Split those apart. So there. Nobody's in class. Set the in class to true, and now everybody went to class all at the same time. So I'm using that static property to send all the students to class. It doesn't affect one. All students go to class when I set that to true. All right. So I could also put a method on here, a static method, right? I can have it return void, go to class, right? And in class equals true. Now, this reference to in class is referencing the static version here. I should technically prefix it with the type name when I'm dealing with a static, because it's not available to the individual types, right? The individual instances of it, because it goes across all of them. Eternal Devcoder asks, that's a good question, let's bring this up. Can one property be static in a non-static class? Yes, that's exactly what we're doing here. The property in class is static, and I'm creating instances of it. Static class requires all content inside of it to be static. Well, let me show you that in just a second here. I'm going to change this and say student dot go to class, and it forces them all to true. I can't say students 0 go to class, and that doesn't work because go to class is a static, right? It's a method on the student type. All students go to class. You can't just tell Hugo go to class without telling Fritz and Lily they need to go to class also. Everybody goes to class at the same time. Sure. You want to do that? We can do that also. I see what's going on there. We can also do ditch class and have all the students ditch class as well. So we can't say, hey, just Hugo ditch class. No. All the students ditch class together, and the teachers are out of a job. You get the point. But so there was a question there that came up from Eternal Devcoder, and this will be the last question that we hit as part of this episode, is about static classes. So not only can you make methods, properties, fields, events static, but you can also make an entire class static. So if I have a static class, and this is something where you might stash, well, we had static classes we talked about when we made extension methods. You might have a static class that contains various features that you might want to have as utility methods that are just available out there. Trying to think through a simple example of a static class, an extension method, a simple, right? Maybe you have, I don't know, date methods, methods to work with the date time. So maybe we have an int for the year difference, right? Or let's call this calculate age, right? Date time. Let's call this date 1, date time, date 2, and whatever. You're going to do whatever that calculation is. I'll write an appropriate method here and save it into the notebook. But for right now, I'm just going to return 10, just so you can see what this looks like. You can't have this as an instance. Everything inside of here must be static as well. You can't have instance variables, properties, fields, methods. Everything inside of the class must be static. So now I could say display date methods, calculate age, date time now, whatever. Doesn't matter, it's going to return 10 anyway. But the point is, it's, right, that helper method, right? You'll see these helper methods declared in static classes like this. But at this point, because we know about extension methods, why not just turn this into an extension like that? And instead of saying date methods calculate age, right, I can say datetime dot now calculate age, like that. And extension methods don't work here because of how .NET Interactive makes these available. So this would be one way to do it. And even then, calculate age, I wouldn't include a second parameter. You're calculating the age up to now. So there we go. All right. So all right. Yes, Ubuntober. That's a promotion that we're doing over on my channel. Let's wrap things up. Let's head over to here, and yeah, let's call it a stream. I think that's a stream there. So this was Errata review number 1. Going back over the last 6 episodes that we had together, talking about some things that we missed, filling in some of the gaps, answering some further questions around the topics, around the features that we were working on, and making sure that you have just a little bit more in your toolbox so that you can go forward and build better applications. Thank you so much, chat room. Really appreciate you hanging out with me there, talking about ditching classes. Look at that. It's been great to spend some time with you together here on this Monday. I'll be back again next Monday. We'll talk about, we're going to be working on interfaces, abstract classes, and error handling next time. And I hope you tune in. If you're watching the YouTube video, it's going to be the next video after we get done recording it. I hope you either tune into Twitch and watch us live, or you catch that next video when it's published later in October. Thanks so much for watching. I'll see you next time.